that energy method is specifically brought here. Why not any other thing that one? So let's do one thing. So when the charge particle is somewhere here, let's see that when it is here, what are the forces that will be acting? The force here will be acting like this, no? As as the charge particle moves on the bisector, so it will be located symmetrically. So the force, magnitude of force acting will be equal. So what this force will do, will make it undergo retardation, and finally it is made to come to instantaneous rest here, no? Then what is the expression for acceleration? So the expression for acceleration, we do write 2f cos theta by m. So let this distance be x. Let this distance be r. So what is the formula? This will be 2k q naught m r square. Cos theta will be x by r. So this everything will become this much. Look at now, as it moves, what will happen to its acceleration will be variable. So if you just go for further simplification, I think what is r? R you can write it as d square plus x square. So this, shall I write directly? D square plus x square to the power of 3.
Sir,
Voice is breaking up.
Sir, your voice is breaking, sir.
Now can you hear me? Is it
Yes,
okay?
sir.
Now fine, sir.
Oh, fine. Huh? I'm writing the equation directly. So look at this. What is the question like? I wanted to ask you, like this x has to be calculated. So what you do, v dv by dx. Try to have both approaches, mathematical as well as energy method. Tell me what is the thing. Provided if you are very good in integration, I think you can work out, no? So the equation finally it will end up with v dv is equal to 2k q naught m d square, no? It should be. I'll integrate. Initial velocity of projection is v naught 0. This will be 0 to x. I think it's undergo retardation, no? So that negative sign will adjust here. So provided if you are very good in maths, then only will reach the answer. So for a person without having the mathematics, now there's a one question like this where some little bit easier integration also brought it. Some situations happen even you can't integrate also. If we do end up, then what is the alternative available? The alternative available is the energy method. Then what are the forces that are acting? Electrostatic force. So which force is doing work? Only electrostatic force. And what it does negative work. So what should happen now? Potential energy should increase here. So this. So now the decrease in kinetic energy of system will get converted into increase in potential energy of system. So I'll go for directly conservation of mechanical. Means like in electrostatic field, can you apply conservation of mechanical energy? Yes, you can apply, because what is electrostatic field? Is a conservative field. So this F is what? Is a conservative. So just now we concluded, no? Applying conservation. So initial interaction potential energy plus kinetic energy equal to UF plus KF. Initial interaction potential energy 2K Q naught by negative sign. The charge is interaction. Substitute charge with sign. It is Y2, because twice it is interacting. No, also like it is Q naught is interacting with both the charges plus initial kinetic energy equal to finally at addition. So K Q naught X equal to 0. Tell me, I think this will be most easiest way of getting answer, no? You see, no need of any mathematics.
Minus, sir.
Yeah, minus sign. I'll bring that minus sign here. You see the approach, energy approach will really minimize the mathematics, no? That's the only purpose of bringing electric potential concept here. So next we are going to discuss the electric potential. So why that electric potential is what? The first purpose of potential is to minimize the method, to eliminate the mathematics. Later on, it got its own further the features where the then field what the potential will become so important. The application of electrostatics is what? The potential, electric potential. The electric potential will help us a lot in the application than electric field. And this was the story started like this here. So this is another alternative approach. Or so you do have one side the force method, and here is what? The energy method. So solving for x what happen, we'll get the required answer. This unknown thing which we have to find out. The same unknown thing you are supposed to determine by your integration. So you do get plenty of application. There's no limit. Like F equal to Q, here also the same similar situation. There's no limit like and all. So you can bring with any of the electrostatic, any of the conservative field. The electrostatic field is there. Any other conservative fields also will be mixed up with this. Okay, just do make observation. We'll go for next one.